In this video, we'll discuss the quadratic function. Actually, this is the part 2 of the mathematical modeling. So the part 1 is the linear function, and this part 2 is entitled the quadratic function. Okay, so when we say quadratic function, we have this equation form. We have the function of x is equal to ex plus bx plus c, where x here as the domain, and we have the function of x or y is the range. The a and b are the real numbers, while c is the constant, also a real number. But a uses for the coefficient of the second degree variable, while b is the coefficient of the first degree variable, and the constant has a 0 degree variable. Okay, so a quadratic equation is a second degree equation. So any equation that has a second degree is actually called as the quadratic equation. Now, parabola is part of it. Parabola is a quadratic equation. It is coming from the quadratic function. So therefore, the parabola actually derived from this function. Now, when we say parabola, by definition, this is actually the set of all points in a plane equidistant from a fixed point and a fixed line. So the fixed point is called as the focus, while the fixed line is called as the directrix. So if this is the Cartesian with origin 0, x and y, so if this is the parabola, we can call this as parabola if we have the vertex and we have the focus. Okay. Now we have also the directrix, and it has the equation of y is equal to negative p. So therefore, this line directrix did not touch the parabola, while the focus is actually touches the line. The line which is the latus rectum passes through the focus will touch the end of the latus rectum will touch to the both sides of the parabola. So the line that connects from vertex towards the focus is actually called as the axis of symmetry. So therefore, we have there are points of symmetries. The points in the curve are actually symmetric to the opposite side of the graph. Now, by definition, parabola is a set of all points. So, for example, I have this one point in a curve, then call this as P, whose coordinate is xy at any point. Then this point of the focus, it has the coordinate of 0 and P, because by definition this would be equidistant. So whatever distance from vertex towards the directrix is the same as the distance from 0 to the focal point. So therefore, it has a coordinate of 0p, while the origin is 0, 0. So therefore, at this point is xy. Then at point here, constructed vertically towards x, extended as intersect to the directrix, and let this be equal to q. So we have x coordinate as an abscissa minus the p. P is actually below the negative p is below the vertex. Again, directrix is lying on the y is equal to negative p. So therefore, this coordinate must be x and negative p. Okay. So from this equation, equidistant. So this distance, the vertex from the focal point, from vertex to focal point and vertex to directrix line must be equidistant. Also with this line the point P towards F is equidistant to the point P towards Q. So therefore this line must be the same. Okay, so now the equation of this parabola is y is equal to ex squared. So a, remember, is the coefficient of second degree variable, and y is actually the function of x. So this is pattern. And in this case, constant is 0 and b is also equal to 0. So therefore this term will be eliminated. So in this case, the vertex is located at the origin. So we have only ex squared. So therefore, for the quadratic function, if b and c are 0, then the vertex is located at the origin of the Cartesian. Okay, the question now is, how did y is equal to x squared arrive? So how to obtain this one? So in that case, we will use this definition of equidistance. Now take note that the PF, this one, is equivalent to PQ. So therefore, this line must be the same. Also, if you have this at this point, if you connect this from the focal point, it should be equidistant. So any point in the curve is always equidistant from the focal point towards the directrix line. So for example, this one, if I point this one, connecting this line should be equidistant to the distance towards the directrix. So it should be perpendicular to the directrix line. Okay, so using the distance formula, the length of this is actually, using the coordinates, should be x minus 0. Okay, and we have what? We have squared, then we have y minus p squared, then take square root. So therefore, this is the distance of the point. So take note, this is at any point. We cannot say that y is equal to p. So this is representing at any point. So using the distance formula, the distance of p to f is square root of x minus 0 square plus y minus p squared, using the distance formula. You have to recall your distance formula. Also, therefore, whatever length here should be the same. So the length of PQ is x minus x. And we have the y minus p. Y minus p, then squared. Then take square root. So therefore, this will be the result. Again, the PF is x, this one, x minus 0, then square it, plus y minus p, then square. So this is now the distance. The distance of what? The distance of PQ using the distance formula. And PF and the PQ is x minus x, this one, squared, plus y minus. So therefore this will becomes plus, because y minus, then minus p, so negative times negative becomes positive p, so then square it, then take square root. Okay, so therefore this is not the relation. This relation now involves the y, p, and x. Now if you square both sides, this radical sign will be removed. Okay, because this is 1/2 raised to 2, then it will be cancelled. And this is, take note that this is 0. And this one is x squared, and this is square of binomial, and this is also square of binomial. So when you square the binomial, by the way, this is x squared, this one. Square the binomial, square the first, recall your algebra, square y squared, then twice the first and second, it should be 2 minus py and square the last, it should be plus, because when you square the negative, so therefore this is the expanded form of the square of binomial minus. Then this is 0, so eliminated. Now we have another square binomial. Square the first, that's it. Twice the first and second, this is plus, so plus 2 py squared, the last p squared. So this is the simplified form of the above equation. Now notice that there are terms that can be cancelled. Look at the y squared. Y squared can be eliminated. And the p also can be cancelled. P squared. So what we have, we cannot cancel negative 2py because this is positive. Instead, we can combine these two. So if you transpose this one to the right side, this will becomes 4py. And we have x squared is equal to 4py. Okay, so this is on the relation, meaning when you square x, it is equivalent to 4 times p. Take note, p is the distance from what? From vertex towards the directrix. That's p. Multiplied by y. And this is the variable. X and y are variable. Okay, if we let a be equal, take note, this is a. If we let a be equal to 1 over 4p, then this will becomes what? This will becomes x squared is equal to 1 over, because the reciprocal of 4p is a. So 1 over a is equal to 4p. And what else? Multiplied by y. So this is the y. So if you take a diagonal product, cross multiply, y is equal to ex squared. So this is how to obtain this equation. Okay? So therefore, we will be using this equation parabola. This is the equation of parabola. And this is limited only when the vertex is located at 0. Okay, so this is it. X squared is equal to 4py, or it can be y is equal to ex squared, because a is 1 over 4py. So how will we use this one? We can use this if the vertex is located at 0 and the parabola opens upward if a is what? Is positive. Okay? So what will happen if the parabola is open to the left? So if it opens to the left, so the vertex again is the origin. So the directrix now is a vertical line. So remember, the vertex line of directrix did not touch the curve. It has a distance, equidistance from the vertex called p. This is p, remember. Distance of the origin towards the directrix line is p. And equidistance to that is the focus. Okay, so the same. Directrix, focus. So whatever distance here will be the same. So this is negative p, and this is positive p. So this is now the latus rectum. The latus rectum is a line that passes through the vertex, focus, and it is parallel to the directrix line. So we call this as the end point of the latus rectum. So again, negative p and positive p. So they must be the same in magnitude. And these are the points of the latus rectum. So this is the axis. The axis of symmetry is lying on the x-axis. So this is for the parabola open to the right. So the equation must be now reversed. We can the same derivation as we did in our previous slide when the parabola is open upward. This one, y now becomes squared is equal to 4px. If the parabola open upward, then this should be x squared. If the parabola open to the right, it should be y squared. So y squared is equal to 4px, or this x now is ay squared, where a again is the same as 1 over 4p. So therefore, take note that when the parabola opens to the right, you have to square the y, and the x is not. When the parabola open upward, x must be squared. So for a parabola open upward, we call that as a quadratic function. It is a function, but the parabola open to the right or to the left is not a function. But we can break that into two functions. Okay, so therefore the equation of this parabola is x is equal to ay squared. So we have to remember this one. This is very much important. Okay. Now suppose given y is equal to 1 over 8 x squared. The question now is find the equation of the directrix line. So remember, directrix is the line from the origin at a distance p, and it did not touch the curve. Directrix will not touch the curve, the parabola. Then next is you are asked to find the vertex of the parabola and the focus, meaning you have to give the coordinate and find also the equation of the axis of symmetry. Then you have to provide the graph of the parabola. So first solution is, take note that using this equation, a is equal to 1 over 8. Okay, so a is equal to 1 over 8. So the parabola here is has a coefficient a 1 over 8. Now take note, a is 1 over 4 pi. So you can equate the 4p, 1 over 4p. So therefore, a is 1 over 8 and a is 1 over 4p. So we can solve for p. So p by calculation is 2. So therefore, from the origin, take note this is positive. So therefore, it should be what? It should be below, because the parabola is opens upward. So therefore, p must be in and below the vertex, because this one is the directrix line. So directrix line did not intersect the parabola, so therefore it must be located below. If the parabola open downward, then the directrix must be above. Okay, so this is the directrix line. So therefore the equation must be what? Y is equal to negative 2, because the additive inverse of this value is actually the equation of the directrix. Okay, so our first answer is the equation of the directrix line is y is equal to negative 2. So therefore it is a horizontal line. Okay, next is the vertex is located at, because you are asked to find the vertex is located at point 0, 0 at the origin. So remember that this equation signifies that the parabola has a vertex at the origin, because b and c in the quadratic function are 0. So therefore, this is the answer for the vertex. What about the focus? The focus is actually equidistance from the directrix to the origin. So therefore, you have to construct, because this is 2 units, so you have to construct another 2 units, then that's the focus. This is the focus for the focal point. So the focal point now is actually at 0, 2. X is 0, y is 2. So therefore, this is the focus point at 0, 2. So we already answered. Now, the axis of symmetry is the line passes through, the axis of symmetry will be passes through the focal point and the origin. So therefore, you have to connect this with a straight line. This is the axis of symmetry. So therefore, this is what? It has the equation of x is equal to 0. Okay? So, vertical line is, and passes through the origin, x, it has an equation of x is equal to 0. Okay? So then, this is the axis of symmetry. So therefore, we are now ready to, by the way, if take note that this is the latus rectum. So if these are the end points of the graph, okay, so the end points of the graph will be the latus rectum. So the length of this is the semi latus rectum. We call it as a semi-latus rectum, but the full length is the latus rectum itself. And the end point of this is we have from negative 4 and 2 to positive 4 and 2 coordinates. So these are the coordinates of the, or the endpoints of the latus rectum. Okay, so this equation is 1 over 8 x squared. This is the answer. Okay, so this we have to graph. So you have to provide this. You have to draw this to scale. So why is it this is 4? Remember, this is x. So therefore, by the way, this is 2. Okay, this is 2. If you substitute 2 to x or to y, then you can solve for x. So therefore, this must be 4. This must be 4 because when you substitute x or y with equal to 2 here, then the result is 4. Plus and minus positive 4. So that's the end points of the latus rectum. Okay? So this is the answer. These are the answers to the problems. Directrix line, vertex, focus, and the axis of symmetry. Then the graph is a quadratic or a parabola, opens upward. Okay? So that's it. So remember that if you construct a line here, touches to the curve, it should be equidistant towards the focal point. Or in this point, if you have this one, then it should be equidistant. So this line must be equidistant. So therefore, you can construct a parabola by doing this one. So a series of points, if you connect all points here, then you can create a parabola. Then connect all the points. Okay, another problem is find the equation of the parabola if focus is at 0, negative 15, and directrix is 1.5. No, negative 1.5. And the directrix is y is equal to 1.5. Then plot the graph. So in this case, in previous problem, we are given the equation, but in this case, there's no equation, but we have to find it, and given only the focal point or the focus, coordinate of the focus. We have the 0 and negative 1.5. So therefore, the directrix is, by the way, the directrix is located at y is equal to 1.5. Remember, this is positive, so it is above the horizontal. So therefore, okay, the focal point is 0, negative 1.5. So below, this is now the focal point. And the directrix is what? Y is equal to 1.5. So we have to construct here. This is the y is equal to 1.5 directrix. So it is above. So therefore, obviously, because the vertex is located at the center, at the origin, so therefore the parabola must be open downward. Because the rule says that the points of the core of the parabola did not touch the directrix line. So therefore, okay, so in that case, our P is negative. P is negative 1 because this is our P. And this is a positive. This is P, downward. Sorry, this is downward P. So therefore, this should be negative P. So in that case, from the formula, A is equal to 1 over 4P. Substitute the negative here, 1.5. Then we come up with A is equal to negative 1 over 6. So, reminders, if A is negative, then the parabola opens downward. If A is positive, then it should be open upward. So therefore, this is a parabola open downward, whose A is negative 1 over 6. So therefore, we can now formulate the equation of the parabola. It should be y is equal to ex squared, but A is negative 6, so negative 1 over 6 x squared. And this is the equation of the parabola. When y is equal to 1.5, this is the value of P. So when you substitute y here, you can solve for x. And the x is plus or minus 3. So therefore, this will be the end point of the latus rectum at the x-axis. So it should be negative 3, and 1.5. 1.5 is this one. So therefore, the coordinate, this is the one end of the latus rectum. Another end is the opposite side because we have this as the point of symmetry. So we have y is equal to 3, then negative 1.5. So these are the end points of the latus rectum. Then the graph will be passes through that points and the curve. So you have to connect it by a curve. So actually this one is the reflection of the side. So you have to draw it carefully and make sure that we have the equidistance. Okay, then so therefore we can say that the end of the latus rectum is at negative 3, 1.5 and 3, 1.5. These are the answers to the problem. The equation is this one, and the graph is parabola open downward. Okay, so in general form, the equation of parabola is actually y minus k is equal to a times x minus h squared. So this is the general equation of the parabola. Why? Now in this case, h and k are actually the x component, x and y components of the vertex. So therefore this holds the vertex. So we call this as general equation of parabola. Why? Because remember in our previous slide, we are binded with the origin lying, the vertex lying at the origin. So therefore, the parabola might be open upward or open downward. What function? Now in this case, because not all the time that the vertex is located at the origin, it can be anywhere. It can be in the along x or along y, or it can be in quadrant 1, quadrant 2, quadrant 3, quadrant 4. So what will be the equation? This will be the equation. Okay, so for example, if the vertex, because remember you have, this is the abscissa of the vertex and k is the ordinate. So suppose located in the first quadrant, and the parabola now is open upward. Why? Because this is positive. So therefore this is the equation of the general equation of the parabola. So if a is greater than 0 means positive, then the parabola opens upward. Now what will happen if this is negative? What will happen if this is negative or less than 0? So the parabola opens downward. Okay? So h and k might depending on the value of the coordinate of the vertex. So it can be second quadrant, first, third, fourth. If a is greater than 0, it should be upward. Open upward parabola. But if it is less than 0, open downward parabola. So that's it. Now what will happen if h is 0 and k is 0? So if you substitute here, so you will go back to our previous slide that the parabola rests on the vertex. So therefore, you end up with an equation of y is equal to ax squared, or might be y is equal to negative ax squared. So it can be open upward for the positive a, or open downward. Okay? So take note, this is the equation of the parabola we used in our previous slide. So in this case, this is the general equation of parabola. So you're advised to use this one. Okay? Because this can solve the parabola at any point of vertex. Okay, so that's it. So for example, suppose we are given we are asked this problem: find the equation of the parabola if h is equal to negative 4. Okay, given the h and given the k of 5, given a is equal to 3. So if given the coordinates, take note, this is the coordinate of the vertex, and we have this a value. So therefore, we can use this equation. All you need to do is substitute h here algebraically, k here, and we have a leave x and y, because x and y again are the variables. It brings with variables in order to call it as an equation. Okay, so you do not substitute the x and y in that case because you are looking for the equation. Okay, so then do it. Substitute. K is 5 positive, A is 3 positive, H is negative 4. So algebraically substitute. So negative becomes plus. So this should be x plus 4 squared. And this is minus. So y minus 5 is equal to 3 times x plus 4 squared. So then use your algebra, expand, then solve for y. So in that case, if you expand this one, this is x squared plus twice the first. So 8x squared the last 16. Then distribute the 3. So we have 3x plus 24x plus 48 plus 5. So we can combine these two constants. So we come up with, this is the quadratic function. So this is the quadratic function. The function of x is 3x squared plus 24x plus 53. So therefore a is 3. This is a, 3. And we have this, the b is 24 and the c is positive 53. So b also is positive in this case. So what do you think? What's the graph of the parabola? What's the form of the parabola in this case? So in order to construct the graph of the parabola, you need 3 distinct points. We need 3 distinct points. What are the 3? In linear, we need only 2. No? We can emphasize the graph, but for the parabola, we are required to have 3 points. So in this case, okay, we need the vertex. So this is 1 point out of 3. So we have negative 4, okay, and this is 5. So you have to count, because this is negative 5, count here, let us say that point, and you have to move upward because positive. So we have approximately this is negative 4 and 5. This is the vertex. And remember, A is positive. So therefore, it should be open upward. Okay? Actually, you can solve for P here. Then use the same procedure. Solving P, then you have to find the directrix line is below. Okay, you can do it. But in this case, I will provide the graph using the 3 important points. So vertex, then another is the y-intercept, because we can easily find the y-intercept because we are given this equation. Without this equation, then you cannot use this strategy. You have to go back to the previous style of graphing. So in this case, since we have already the equation, substitute x be equal to 0. So when x is equal to 0, y is 53. We call this as the y-intercept. So you have to locate it, and this is at 0x 53. So this is the y-intercept. So we have now the 2 points. So therefore, take note that the axis of symmetry will pass through the vertex. So and the parabola is open upward. So therefore, the vertex must be the axis of symmetry must be the y, or the vertical line. So we have this axis of symmetry. The axis of symmetry means the points in the right is actually the image of the points in the left side. So we call that as the points opposite to this line is called as the point of symmetry. So there are points of symmetry. The point of symmetry is located in the opposite face of the parabola. So if you connect a line here, actually this will form a curve, which is 1/2 of the parabola from the vertex. So you have another curve here. So therefore, these are the points of symmetry, symmetric to these points also. So since we have this 1 point, this is the axis of symmetry, or this is the y-intercept, then we can create axis of create the point of symmetry in the opposite. So remember that the vertex is located at what? X is equal to negative 4. X is equal to negative 4. So therefore, this should be the line. So negative 4 from here, negative from this origin towards this point, this is negative 4. So another 4 here is negative 8. Okay? So the abscissa of the point of symmetry is negative 8 and the y is 53. So therefore, this is it. negative 8. Why negative 8? Because we have 2 negative 4. So twice the negative 4 is the actually the x of the point of symmetry for of the y-intercept. So this must be negative 8 and 53. So these are the three importance. Okay? Now all you need to do is to connect this with a smooth curve. Take note that this is the parabola. So you have to connect a curve here. Then you have to create. So therefore the point of symmetry is negative 8 and 53. So therefore this is the graph of the parabola. Given the h negative 4, k is 5 and a is 3. These are the answers to the problem. Okay, now the question is, where did they arrive this equation of parabola? How do this equation obtain? So in this case, we will derive this relation. So actually this parabola, as I've said a while ago, that the parabola is derived from the quadratic function. So we will obtain this one using the quadratic function, the ex squared plus bx plus c. Now all you need to do is to what? You have to transpose c opposite side, and we will complete the perfect square trinomial of ex squared plus bx. Then after that, we will factor, then transform, and we will arrive at this point. Okay? So, we will transpose c, okay, do it, c to the left side. So, leaving only ex squared plus bx. So, this is now consists of two terms. We can add here a term that makes this a perfect square trinomial. So, we call that as completing the square. So, the process is completing the square. So, all you need to do is to, what? Is to divide both sides by a first. So, you have to divide both sides by a. This y should be divided by a. That's it. C divided by a. And this is divided by a. So, we have only a squared. Bx divided by a is b over ax. So, this is now, we can now create the perfect square trinomial. So, we have to add something. Okay, so this is by completing the square process. How to complete a square? By completing the square is to create a perfect square trinomial. So, a perfect remember, the perfect square trinomial has a factor of square of binomial. So, therefore, vice versa, if you if you multiply, if you square a binomial, the result is a perfect square trinomial. For example, this one, x minus h raised to 2 square. So, this is a square of binomial. And you expand this one by multiplication, the result is a perfect square trinomial. So, this one, we will complete this, completing the square, so that this will come up with a perfect square trinomial. So, once perfect square trinomial, then we can factor we can find the factor which is square of binomial. Now, the question is, how to obtain the last term to become complete or perfect square trinomial? Very easy. You have to divide the coefficient of the coefficient is of the first degree variable is b over a. You have to divide the coefficient of the first degree variable by 2, then square. Again, to obtain the third term to become perfect square trinomial is to divide the coefficient of the first degree. This is the first degree variable x. This is the second degree. So, divide the coefficient of the first degree variable by 2, then square. So, all you need to do is to do it. So, b over a divide 2 will result b over 2a, then square it. So, this is now a perfect square trinomial. So, we will be adding b over 2a square. Now, since we add a term here, in order not to break the sign of equality, to maintain the sign of equality, we need to add the same value in the opposite side to make them equal. So, therefore, in this case, left is always equal to the right. Okay, so nothing was changed. It just expanded. Okay, so then, because this is already, by the way, you can square this one. This will becomes b squared over 4 over a squared. While this one, you can factor. this is a perfect square trinomial, so it has a square of binomial. So in that case, okay, expand first b squared over 4a. So then next we can now, this is now, remember this is perfect square trinomial, so we have the square of binomial. So all you need to do, take the root of the first term. So this is perfect, remember, so this is x, and this is already perfect, so take square root is b minus 2a, then this is plus, so we have to add then this squared. So this is factoring perfect square trinomial. I think you have to review the factoring process. The factoring perfect square trinomial provides square of binomial. This one, we combine these two constant because y is isolated. So combine this by fraction. So we come up with 4a squared minus b squared over 4a squared. So review your fractions here. So negative is maintained. So this is negative because we have the sign preceding, so, and we have the grouping symbol. So we have this negative and this is plus, but you have to change this from positive to negative. So that when you substitute when you transpose the negative here, it will go back to the same sign. And the common factor is 4a squared. So take the LCD, okay, least common multiple. So then you will arrive this one. So the LCD divide A multiplied by C for AC. LCD divide this one is cancelled, so we have only B squared. So therefore, this is it. Okay, we are almost arrived to remember, we do the complete in the square in order to create similar to this result. So we notice that y is already also isolated, and the x also, remember x is here. So we are now in the position of x. Okay? Now next is, take note this y doesn't have the denominator and coefficient. So all you need to do is to, what? Multiply both sides by a. Okay? If you multiply both sides by a, this becomes y. And this a squared now becomes a. Because if you multiply both sides by a, again, a is cancelled. This one multiplied by a. This a squared will be cancelled by 1. So we have only 4a. And we have a here. Okay. So this is, take note that this is already in the form. Look at this one. A. This is binomial, square of binomial. And we have y. So in this case, okay, if we have already this one. So therefore, this is already k. Actually, this is already k. Now, because this is minus, we can use the sign preceding so that it comes up with what? It comes up with a negative b over 2a. So look at this one. So in this case, in other words, in order to have this one, h must be what? H must be negative b over 2a. This one. This must be h. And this must be k. So in that case, h is equal to negative 2 of b over 2a. Then k must be equal to 4ac minus b squared over 4a. So if you do it, then you are deriving this equation. So therefore, we can say, in the equation with parabola, general equation, y is equal to y minus k is equal to a times a is x minus h squared, quantity squared, where h must be what? Negative b over 2a. So we have this, actually the formula to obtain h, and we have this value of k. Okay, so this is very easy to recall, but this one is quite complicated. But all you need to do, if you have already the value of h, you can substitute the value of x. Remember, h is x. So if you have the value of h, substitute here, and you will arrive the value of k actually. Okay, you are arrive. The result must be k. So you can verify this by substituting here, and you will arrive this value. Okay, so again, this is the derivation. As I said, it is good that you can derive. Do not use the formula if you cannot derive. Very important. Derivation is very, very important. So it's quite complicated at the start, but as you go on, Actually, you are reviewing all the basic mathematics while deriving. So, okay, so therefore, we can say that we can transpose this one, transpose this to the right side. Now, if you substitute these values of h here, you will go back to this equation, actually. Okay, so that's it. Now, let's have the example. The example is given the function. Okay, given the function 4x squared minus 3x plus 1. Find the vertex. We are asked to find the vertex. So all you need to do, and the y-intercept, then you have to have the point of symmetry. So therefore, these are the points that we need, that we can provide the graph actually. So point vertex, y-intercept, and we have the point of symmetry. So from the equation, they will start here, then do it the same as we derive this formula. Okay, so transpose 1, then you have to complete, divide both sides by what? By 2, so that this will become x squared. So divide both sides by 2, this becomes y over 2, 1 half, negative, and this is x squared, because we divide by 2, and this is, why is it what that we divide by 2? The reason is so that we can create a perfect square trinomial. So therefore, we are now ready to complete the square. So by completing the square, you have to divide this by 2. Remember, the strategy of finding the last term to become perfect, divide the coefficient of the first degree variable by 2, then square. So it should be 3 over 4 square. So you added a term here, so you must add the same term in the opposite side. So then, combine, this is 9 over 16, okay? And this is the perfect square trinomial, so it has a square of binomial. To find this value, just take square root of this, so you have x. Then, this one should be take the square root of this, becomes 3 over 4. So automatically, you come up this point. So it should be, whatever sign here should be the sign, minus, because this is minus. This is always plus. A perfect square trinomial, the last term always plus, and the first term also always plus. So the middle term will carry the sign of the binomial. If this is negative, negative is plus, plus. Okay? So combine this by fraction again. Your algebra is very important. So we transpose everything so that we have only y. So then multiply both sides by 2 so that we are solving y. So this will become the result. We have, okay, this becomes 2. This is 9 over, because we divide it by 2. Because we multiplied by 2. So then, okay, combining this 1 minus 9 over 8 is this one. Then, okay, then simplify. We can transport, we can return this constant to the right side, left side, forming this one, because we are our drive is to come up with this equation. So then transform, then this is negative, minus, so therefore sign preceding, this our h is what? Is positive, because this is already minus, so it should be h is equal to 3/4. While this one is positive, so take the additive, x is negative 1 over 8. So therefore, these are the vertex 3/4 and negative 1/8. So we answered letter A. So the y-intercept is what? The y-intercept, if we substitute x be equal to 0%, if you substitute here, x is equal to 0, the answer is 1. So therefore, the y-intercept is located at 0, 1. Where is your point of symmetry? And the point of symmetry is, all you need to do is to, what? Is to have the 3/4. Remember, the vertex is in 3/4, positive and below. And the parabola is what? The parabola is open upward, because A is 0, so open upward. So therefore, your y-intercept is located at 0x, 0x and y, okay? And you have the vertex. So therefore, by the way, this must be times 2. So this should be 3 halves, sorry. This must be 3 halves. This must be 3 halves. This must be 3 halves. Okay? So change this to 3 halves because we need two 3/4. So 2 3/4 is 3 halves. So the point of symmetry is located as 3 halves and 1 because the y-intercept, the vertex is at -1. So we have the, and this is the y-intercept is 1. So therefore this should have the same. Okay? So that's it. Now another way to solve for the vertex. Another way to solve for the vertex is actually using the formula previously we derived for h. So remember that our equation is 2x squared minus 3x plus 1. So a is 2 and b is -3 while c is positive 1. Okay? So using the formula, h is, remember in our derivation that h is negative b over 2a. Now all you need to is to substitute everything here. So then we can have the result. This is 3/4. Okay, so this is already our h value. And we have the formula of k. But, as I've said, you can, since we have already x here, h, so you have substitute the 3/4 here, x, then simplify. So we will come up with what? We will come up with, expand this one, combine, we will come up with k is equal to -1/4. So we arrive this one. So our h is, our vertex is 3/4. Sorry, this must be, okay, so there is a discrepancy in our previous slide. Now all you need to is to change this. So we go back to the, this is actually, h is, so this should be 1 over 1, -1/8. Okay, and this should be in our previous, double check our discussion in the previous slide, it should be -1/8 also. Okay, so therefore in this case we can solve the h value using the -b/2. I think this is the ideal one. I showed to you in the previous slide using completing square, but again, this is the ideal solution. This is the ideal solution to solve for the h value because it has a short, and we already derived this in our previous. So our previous solution, take note that we have you must correct the previous solution as 1/8 instead of -1. So it should be 1/8. Okay, so when you have this one, this is, take note, this is 7/10, so it should be -/8. That's it. So this is correct. Okay, now what will happen if you are given 3 points, distinct 3 points, and you are asked to model a quadratic function? What will you do? Okay, now all you need to do is to use this formula. Now remember that this one is the x value and this is the y value. This is x value and the y value. So we have 3 values of x's and we have 3 values of y's. So one at a time, you have to use this coordinate, substitute x here, then solve for, and y is here, then solve for the constants. Because if we are going to derive the quadratic function, we must have the values of a, b, and c. So we will solve a, b, and c, and we can solve it using these 3 values of, or points of x and y. Okay, so start with the first point, then substitute the values of y and x here. So this is the result. Then simplify, leave this as equation 1. Okay, then for the next point, substitute again, go back this one, substitute the x be equal to 0, then y is equal to 1. So then, therefore, in this case, we are able to solve for c. So our c is already 1. Leave this as equation 2 because we need that. So we know already c is equal to 1, but we still have the unknown A and B. So we have to continue. So proceed to the third point, 2, negative 1. So then, okay, so we have A, 11. 11A is equal to A for 2 squared, then B times 2 plus C. Okay, then, continue, simplifying. We have this equation, leave this as equation 3. So we have 3 equations actually. Now, if we substitute 2 in 1, so replace this C with 1 because this is equation 2. Substituting equation 2 in equation 1, we come up with A minus B plus 1 is equal to negative 1. So therefore, we have another equation that involves A and B. So A now in terms of B is B minus 2. Leave this as equation 4. Then equate equation 2 in equation 3. So previously we equate 2 in 1. This one 2 in 3. To eliminate what? To eliminate the constant C. So our equation 3 now becomes what? 4A, 2B plus C, but C is equal to 1. So then we have this as equation 5. Transpose this. Okay. Then we can equate 4 and 5. This is 4 and 5 because 4 and 5 involves only A and B. So we actually doing this one, we call this a systems of equations. We eliminate because this is a 3 by 3. 3 by 3, 3 variables and 3 unknowns. Okay? 3 equations, 3 unknowns. So therefore, we reduce the 3 by 3 into 2 by 2. This will becomes the equation 4 and 5 are in the form of 2 by 2. The unknown is A and B, A and B. So C already eliminated. So in our previous this one process, we eliminate one variable and that's C because C is already given as 1. So then, okay, equating the two, you have to substitute equation 4 in equation 5. So this B minus 2, which is equal to A, you have to replace it here. So we come up with 4 times B minus 2 plus 2B plus 10. Okay? Then, okay, we have this. Remove the grouping symbol. 4B minus 8 plus 2B is equal to 10. So then B is equal to 3. Then we can solve for any of equation 4 and 5. So you can use, it's either 4 or 5 to solve for A. Let's say equation 5. So substitute B with 3. So we have 4A plus 2 times 3 is equal to 10. So A therefore is equal to 1. So our A is 1, our B is 3, and our C is also 1. So therefore, substitute here the general equation of the quadratic function. So then we have the function of x is x squared because A is 1 and B is 3, so 3x, and C is 1. So x squared plus 3x plus C. This is the answer to the problem. Okay? So that's it. See you on the next video. The next video is already the limits and continuity of a function.